Alrighty. Alrighty. Welcome to today's session where our presenters will talk about innovations in AWS analytics and data processing. This session is a level 300, and in this session you'll learn more about using AWS's analytics platforms through some demos. But before we welcome them onto the stage, if you haven't already, could you please download the AWS Summit app via the QR codes on the screen. Please join me in welcoming onto the stage Allison, our Senior ANZ Analytics Specialist. All good. And Chris, our Principal Solutions Architect at AWS. All yours.
Thank you.
Okay, so who in the room uses EMR? Or has used? Okay. Glue?
All right.
Redshift? No one? Okay. The mic is working. Yeah, the mic is working. Yeah, okay. So we're here to talk about the different processing engines and some of the recent innovations, and I'm going to hand over to my colleague, Chris. Just get started.
Great. Well, hi everyone. Thanks so much for coming. And look, today we're going to talk about three key areas in data processing and key innovations. So first area is obviously the most interesting one around best price performance at the lowest cost. That's going to be touching on a couple of areas about like easy things you can do, and also probably things that you can just adjust, instance types and those sorts of things. We'll touch on that. We're also going to cover off operational excellence. So how do we actually easily use our environments and not have those 3 a.m. wake-up calls we all love. And then, of course, we're going to talk about how Gen AI can actually help with your data processing engines. So that's going to be really interesting. And we're going to have a demo on that Ali's going to be pushing me quite hard on. So we're going to get into that when we get there. Now, quickly want to talk about what's new in data processing. So I'm guessing today you've heard about SageMaker Unified Studio. The reason I bring it up in the data processing section is all the tools we're going to be talking about, you can actually interact with through SageMaker Unified Studio. As it is today, you've got SQL Analytics and you've got the ability to write Spark jobs and build your applications in Juniper notebooks. But as we move along with and release new features, you're going to see streaming apps and search analytics and so forth being able to be built in there. And the great thing is that it's all sort of in that one environment, that one umbrella, and you're going to be able to use the identity that you have used to single sign-on to be able to access the tools that we're talking about today. Cool, so let's start with how to get the best performance at the lowest cost, which is always near and dear to my heart. It's normally the first question that I get asked by customers is, how can I make this thing cheaper? So let's talk a little bit about EMR. So the typical workloads we see on EMR are either Spark or Trino. And if you just use EMR out of the box today, you're looking at getting a sort of 3.9 times improvement of running Spark jobs on there, straight out of the box, and you didn't even have to change any code, right? You just had to run it on EMR. Similarly with Trino, if you run that on EMR, you're going to see around a 2.7 times improvement of running it just straight out of the box. Now this is a big one, and this is one where you may have to make a small change, where you may move to Graviton instance types instead of your other instance types, and you're just going to see a 20% performance improvement straight out of the box, and that's at 15% lower cost. So a really easy win there from a price performance perspective. Now this number is based on Graviton 3, and Graviton 4 has since been released, right? So I would expect to see even better numbers than that as the new Gravitons get released. Now, I've talked about being able to do all this without having to change any of your code or anything, and that's because we've got this commitment to making sure that we're 100% open source API compatible, right? So all the things I've talked about here, you should be able to get what runs on Spark on your local desktop, should be able to run in EMR without any changes at all, and seeing those price performance improvements that I've just been talking about. Okay, now similarly, this is what Ali calls MWA, and it's actually an interesting acronym, and it's Managed Workflows for Apache Airflow, is for MWAA. It's a bit of a mouthful, so Ali has shortened it to MWA, which is great. Now, typically with Airflow, right, we're using the Celery executor to run, and that does take a little while for those workers to scale back down, right? And so what we've done in Managed Workflows for Apache Airflow, right? MWAA is we've actually got scripts in there now that look to tail off the executors quicker, right? So you actually see your number of executors scale down much faster than you would on the typical open source. And again, you haven't had to do any changes for this, you just need to be using a recent version of MWAA. Okay, now the last thing I wanted to talk about, and this is the one that I wasn't really aware of till I started digging into this a bit, was around Glue usage profiles. It's where you can actually set up profiles that are assigned to roles or users, and you can actually put some limits around how many DPUs you've got, how long the jobs can run, some basically constraints for your Glue developers about how long the job will run for and how much DPU will consume. So really good way to control your costs and making sure that some of a badly written Glue job isn't running away from you. So what I'm going to do now is I'm going to hand over to Ali, who's going to talk a little bit about Redshift.
Excellent. Let's move on to SQL engines, everyone. So this slide is quite busy. It contains a lot of information around some changes and improvements that we've made. So I'm just going to talk about a couple of the ones that are highlighted on the top, which are my favorites. Okay, so let's start with a lot of our customers run dashboarding workloads off Redshift, and from a query execution perspective for those dashboards, we've optimized the code execution. And we've done this by compiling query segments in the background, which effectively means that that compilation and that query response time, the latency, has been reduced for you. The other one up there, the metadata changes. This one's really important to what I'm going to talk about in a minute around data sharing and multi-cluster deployments. But we've made some changes in this, and we've made the refreshes so much faster because that metadata needs to be shared between the Redshift clusters. And we've made this 146x times on that first query refresh. So much, much faster for passing and sharing the metadata to enable that data sharing and cross-cluster deployments. From a system performance perspective, we have released a new RA3L provisioned cluster type. So this is for those smaller workloads that customers may want on a provisioned node. And also, as Chris mentioned before, Graviton. We have rolled out Graviton for 30% better performance across Redshift serverless, with over 64% of serverless loads now running on Graviton. So this is where I'm going to start to just apply some basic principles on what I'm going to talk about from a multi-cluster perspective. So data sharing across Redshift clusters. We have a concept of provisioned clusters and serverless clusters, or serverless work groups, sorry. Provisioned clusters, serverless work groups. Here I have a provisioned cluster. It has multiple compute nodes. That is the compute nodes that need to compile and return the query result, okay? Separately from that, we have the Redshift managed storage, which is underpinned by S3. Now, any time that you add, delete, change any data, that is committed to the Redshift managed storage layer, effectively to S3. When you query data, the Redshift system likes to check, it needs to have that data in what we call disk cache, its memory. So it will check if that data is there, and if not, it will retrieve it from S3. So basically you run a query, it says, do I have the data that I need in memory? If not, it will go and fetch it from S3 and return it into the disk cache. If it is there, it will simply run the query and return. Of course, this is completely invisible to you and quite more complex under the hood than what I've just explained. But this effectively enables that data sharing as well, because what can happen is that metadata is transferred between the clusters. And we just heard that that's got a lot faster. And that can be transferred between another provisioned cluster or a serverless work group, and any combination of those. And effectively what happens is that the cluster gives permission to the other one to retrieve that data into its disk cache and run the queries. Now, of course, this can be done within the same account, across accounts, as well as cross-region, and we'll see a great example of that after. So now that you know what that is, in 2021 we released the data sharing capability, and it was originally on a read only. Now we have just recently made that write capability as well. So multi-clusters reading and writing from the same Redshift managed storage layer. So effectively this allows you to run multiple workloads simultaneously, writing to the same storage layer, enabling you to scale your ETL workloads. So I mentioned serverless work groups. We've done a lot of innovation from a Redshift serverless perspective. And I have seen quite a few customers moving from provision clusters to serverless clusters where it makes sense. And we're seeing up to a 5.3x performance improvement, as well as a 70% cost reduction. So if this is something that you haven't already looked at, I suggest that you speak to your account team. This is now available in 10 more regions globally. We have added additional functionality for parity between provisioned and serverless clusters, such as snapshot scheduling and private link connectivity and much more. We've also expanded the capacity. So what was previously a maximum of 512 RPUs or Redshift processing units has now been doubled to 1,024 RPUs as a maximum, allowing those even larger workloads to come onto the Redshift serverless clusters. Okay, I love talking about autonomics in Redshift. Redshift has a lot of automatic features that run behind the scenes, and the AI-driven scaling and optimizations is another one of these. So this enables you as a customer to select your preference between cost performance and speed performance, and where you would like that on a sliding scale. And Redshift will basically achieve that performance and maintain the workloads without you having to change anything. So this is really helping our customers to meet with their price performance requirements. Now, this is an example that I really love. This is one of my favorite places to shop, Amazon.com, especially when your daughter, like mine does, got invited to Comic-Con with her friends this weekend in Melbourne and apparently has to go dressed as an anime character. And I'm here in Sydney, I don't have time to shop for these things. So Amazon.com, thank you very much for that. But also, this is a great example of everything that I've just talked about from a multi-cluster deployment perspective. We see serverless, we see provisioned, and we see the read-write across clusters, and not just across clusters, but across regions. So this producer fleet has 283 Redshift clusters. It processes 240 petabytes of data, which is growing daily. And of those 283 Redshift clusters, 226 are serverless and 57 are provisioned. So this truly brings together the concepts that we've talked about on performance and scale for a truly data-driven enterprise. So just before I hand back to Chris, just in summary, from a performance perspective, Redshift performance is up to 3x better of any other cloud data warehouse. And we do this through, the MPP processing engine, our columnar storage, our sophisticated optimizer, etc. And from a dashboarding perspective, for all of those low latency, high concurrency dashboard requirements, we are 7.x better from a price performance perspective than other alternatives. Operations, Chris.
Yes, I love talking about excellence and particularly operational excellence. So I'm going to talk a little bit about that quickly now. So the first thing I want to mention is this is a new feature I wasn't aware of. Concurrency and queue management for Glue and EMR serverless. So in the past, when you've had to submit jobs to Glue and EMR, and maybe you've run hit limits around DPUs, or you've hit limits on the number of IP addresses you have in your VPCs, you'll just get an error straight away. What we've done now is we've actually created the ability for you to queue up those jobs, and this function is actually aware of where you are with your limits, especially around IP addresses in your VPCs as you increase the number of jobs that are running. So really handy feature. You can set some details around how deep you want that queue to be. You can also set some length of how old the jobs can be that are in the queue. So really handy feature, and that's just there out of the box. So we've been talking a fair bit about EMR, and I just wanted to highlight a couple of the options that are available in the ways to run it. So we've got the serverless option, so EMR serverless, where you don't have to think about instance types or how many of them or anything. We do all of that for you. If you do want to be more prescriptive about the instance type, say you want more CPUs, or you want some local storage, or you want higher network throughput, you can use the EC2 instances directly, which has been there since the beginning of EMR. But there's now also the option to run that inside your EKS cluster. So if you've got an existing EKS cluster and you've got some capacity in it, you can run some of your EMR jobs in there as well. Now, with those two options that we talked about, EC2 and EKS, don't forget to use spot instances when you can. Now, just keep in mind, a lot of the frameworks that you're using in EMR, like Spark and Trino, have the ability to deal with failure of instances, right? And so Spot is a really great option for this framework. So please make sure you use those because you can save up to like 90% with that. So really, really handy feature there. I'm just going to hand over to Ali. You're going to talk a little bit more about Redshift. Yep.
Yeah, so from an operational perspective, from a query execution plan, we've put in a visual query profiler so that you can visually and graphically have a look at those statistics and details without having to go into system tables. We've also introduced an individual identifier called a query hash. This will help you to identify any track performance over time of any intensive queries that you have running. Now, getting data into Redshift, operationally we're making that easier. Of course, we have our autocopy feature from S3. This is a continuous file ingestion from S3. You define your prefix in S3 that you want to point towards, the Redshift table that you would like to load, and when new files arrive, these new files are recognized. It also keeps track of files that have already loaded and will continuously load them in for you. Operationally, really easy to implement. If you are loading any data manually into Redshift, you should really move to an autocopy, just a slight syntax extension on your existing copy commands. Streaming ingestion, another really easy way to get data into Redshift, and I was really excited, Chris, to see that this is one of the most widely adopted features of Redshift. So enabling this streaming data without having to preload that data and stage it into S3, bringing it directly into Redshift for near real-time insights within seconds. Obviously integrating with our Kinesis data streams, KDS, and our MSK managed streaming for Apache Kafka. Yeah. There's many things with mouthfuls, full mouthful. We have also recently expanded this streaming ingestion, of course, further improving it with cross-account ability as well as purging views, the materialized views using for streaming with simple syntax in SQL. Some other improvements that we have made from a streaming perspective, enhancements in I/O for performance, allowing larger data within those streams, so we can see the details up there on the sizes for the particular streaming tool or engine. One of my favorites is we've also allowed support for external Kafka. So your self-managed Kafka or Confluent Kafka environments. This was really important for some customers that have their own managed environments. On the security perspective, of course, we support MTLS authentication, as well as secure connections from MSK to Redshift clusters. How else do we get data into Redshift and the likes, Chris?
Well,
do tell us.
There's other cool things in the world besides streaming, right? One of the big things that's come up recently is zero ETL of how do we get data from our transactional systems into Redshift much easier, and not just Redshift, but actually your whole lakehouse, right? And so zero ETL is now available for or the Aurora platforms, a number of the RDS flavors, and also DynamoDB as well, right? And that's really a point and click, as we'll see in the demo that we're going to do in a sec. But we've also now got capability of zero ETLing in data from like SaaS products like SAP, Salesforce, Zendesk, and others. And they can come straight into your data platform. Really quite straightforward way to get in. And we'll see how that all happens. Now, there's been a couple of major features that have come out around zero ETL, but one of my favorite ones that isn't listed here is actually the history mode, where you can actually, for every insert, update, and delete that happens on the source system, you'll actually get a history table inside your target, and that will have the valid to and from and an active record in there. So you're almost getting your SCD2 type dimension in there ready to go, without you having to do any of the technical work to make that happen, which is often quite a challenge. And this is really just a point and click scenario. So really handy feature there. So with that, we might as well get into this demo.
Okay, demo. I am a data analyst. I'm a very demanding data analyst. I do not want Chris to tell me when I tell him I want data that he's going to put me on the backlog and it's going to be 2 months before I can see the data that I need to run my business today. So Chris, I need some payments data. I know the payments team, they have a stream of data coming in, they enrich that data and they land it into a DynamoDB. Okay. I want access to that data, the enriched data in DynamoDB, not the stream. Yep. And I also know that we've recently introduced Salesforce and we have our account, customer, and org information in there. I would like that too, please. Now, demand.
Okay. All right, so let's break that down into a few steps, right? You want the DynamoDB data?
I do.
Today,
Yes.
now? Okay, all
now,
right,
please.
great.
Yes.
So luckily, this feature is actually quite easy to use. You can see up here, I'm in the 0 ETL screen. I'm going to go through here and actually select my DynamoDB table that I want to extract data from. I'm going to pick a target. So in this case, I'm going to put it into a Redshift cluster. And then I'm going to hit finish. And I'm going to be able to start seeing my data land inside my Redshift cluster. And you can see here, there's lots of green, which is all saying this is all happening for me in real time. You can see there, my 300,000 rows have all gone over for you, Ali, already.
Excellent.
It's
so there?
I'm probably going to tell you it took me 10 times longer than it did, just so you don't give me a hassle next time. But what I'm going to do now is I'm actually going to do the SAP data. Oh, sorry, the Salesforce data as well.
Salesforce data, yes.
Okay.
Customer,
Okay.
organization, and account, please, Chris.
Okay, all right. So I'm going to go into the Glue 0 ETL section. I'm going to pick from the source types we have there. I'm going to pick Salesforce. Then I'm going to do account, customer, and organization.
Yes, please.
Okay,
Just those three for today.
entities.
Yeah. Maybe tomorrow I'll ask for something else.
I'm then going to pick a destination again, which is going to be my Redshift cluster.
Great.
Okay, and my credentials for Salesforce were all saved in Secrets Manager for me, so I didn't have to do anything there.
Perfect.
And now I'll just pick my target again, and I'm going to hit go. And you're going to see all that data turn up over there in the lakehouse. I promise it's all there as well.
So that's there? That's it?
Yeah. It's all just straight through the integration.
Okay, well show me it there. I want to see the data.
Okay, all right.
Prove it.
So we talked a bit before about SageMaker Unified Studio, so I'm glad your team's using that, Ali. It makes it much easier for you to address the different personas that you've got. So you can see here, we've got our catalog is shown on the screen here. I'm just going to refresh to bring in the new entities we've added. So there's our payments data. And down here is our Salesforce data.
Perfect.
So I'm going to maybe query some data from that with Redshift. I could have used Athena, but I'm going to use Redshift here. And you can see there's the data already for your teams to start building some insights from. Now, I'm not real good with SQL queries.
I am.
So I'm going to use Q, Amazon Q inside the SageMaker Studio, SageMaker Unified Studio environment. And it's going to build a SQL statement for me. Now, one of the interesting things there is that it was able to understand our schema, and when it did the sum, it did the price times the quantity, right? So it actually understood our schema quite well, and we saw our results come out there. Now,
well, I'm glad you're going into notebooks, Chris, because I have people in my team that really like to work in a notebook environment, and they just need access to that same data.
Right. So for the Spark fans out there, we're basically going to be able to do that also inside our notebooks inside SageMaker Unified Studio again. You can see there I've actually got my Spark SQL there, and the output is coming there.
Nice.
Now I've actually got something extra for you, Ali, that I don't think you're expecting from
thank
here.
you, Chris. Do tell.
Well, we're actually able to interact with Bedrock here through our Redshift cluster. And so I know we saw some customer reviews in there. I'm guessing they're not about your team. They're probably about someone else's team. But I'm able to hook that up to the Anthropic Claude model, create a function on the back of that with a small prompt, and actually include it as a SQL function inside my Redshift query.
Awesome.
Right? So in this case here, I'm actually doing some sentiment analysis, and you can see there's negatives and positives, hence why I didn't think it was for your team.
Great. I can start using an LLM like everyone else, just with Redshift SQL.
All
awesome.
inside the console.
Perfect. Thank you, Chris. And on that note, from a Gen AI perspective, let's talk about the innovation in that area. So as a developer, as a builder, you've, I'm sure, already been working with Gen AI when it comes to producing code snippets, creating notebooks for you, helping you debug and find and resolve issues. But there is more. From a Gen AI perspective, we have made it even better. So troubleshooting with Spark. Troubleshooting with Spark can be really difficult, right? Spark is distributed. There are so many places that you can look in logs for errors. It can be very challenging. So we've lowered the time to resolution on this. I'm going to start this demo. We have a job here that is failing, and you will see that you just have to do a single click. It's failed. and we choose the troubleshoot with AI. Now this particular troubleshooting is going to help us find those things that are really hard to find, like the driver running out of memory or skewness of data, something that is causing a challenging error. This particular Gen AI is going to look at your error stack trace, your Spark event logs, your performance metrics, as well as your Spark configuration. So it's going to go and look through all of that and make suggestions to change and uplift that. Very handy for troubleshooting. But also from a Spark perspective, we often see customers that want to move from one version of Spark to another. And I know that from moving from version 2.4.3 to 3.3.0, there was over 100 version-specific changes alone. So this upgrading of code can be quite challenging for many of our customers. So we have this. It is only in preview at the moment, but considering you would likely upgrade your code base in a non-production environment, I don't think that that is a barrier to looking at this at the moment. The Spark upgrades. So we'll see here we've got some Glue 2.0 jobs. We're going to upgrade to a Glue 4.0 job. We are simply going to select an S3 location to put the new scripts, the updated scripts in for us. And then we're going to ask the Gen AI to upgrade that for us. Now what it will do is it will enable us within the console to interact and see all of the changes that it's made, as well as a single click to adopt those changes from those new scripts that it's created. And in this particular instance, it's going to pick up things like the Python language changes, it's picking up API changes, data frames in Spark SQL, APIs, etc. So yeah, what else can you tell us about Gen AI, Chris?
Yeah, so we saw a little bit of a preview of this in Unified Studio when we did the demo of being able to generate text to SQL. That's also available in the Redshift query editor as well. So again, however you're working with Redshift in the console, you'll be able to have the text to SQL capability there. And not only can it write SQL for you based on the entities you've got, but it can also improve the SQL that you have there as well. So definitely give it a try. It's all just integrated into the environment, and you just got to click the little Q up in the corner of the console. Now, the last thing I wanted to mention here is we saw a little preview where I sort of put it in front of Ali and the team, is the integration with Bedrock. So you can see here you can define your function and you define your prompt, and then you can create it as a function for people to use. So really easy way to get started with Bedrock and access to all the LLMs that are available through that. So definitely a good way to get started there. So with that...
That was a lot of content in a short amount of time.
Yeah.
Good job.
Yeah. So look, any questions, come grab us afterwards. And
yeah, thank you so much for joining us.
Wow, what an awesome demo. Thank you for educating the audience tonight about AWS Analytics and how we can use it more effectively when processing our data. Large thank you to Allison and Chris for today's session. In a moment, we will be putting QR codes on the screen. Please do take the time to provide Allison and Chris feedback via the AWS Summit app. And lastly, if you could leave the headsets on the back of each seat before leaving, that would be great. Thank you, everyone.